Hello everyone, this is Jyoti Dodia and welcome to today's webinar session in the PowerVug series. Today's session number 89 and I'm really pleased to have Benoit Marolleau joining us today, and he'll be covering how to create smarter IBM and AIX applications using accelerated machine learning with H2O driverless AI. So without any further ado, over to you, Benoit, if you would like to introduce yourself and then kick off.
Hello, of the IBM Client Center in Montpellier. In that session, I'm going to introduce how to build smarter IBM or AIX applications with accelerated machine learning and H2O driverless AI. This is my team. So for those who don't know me, I'm Benoit from the Client Center in Montpellier, particularly a member of the Cognitive Systems Lab. So I'm part of this team, and so our activity is basically co-creation, hands-on, technical support for customers and business partners in Europe and Middle East Africa on all kinds of technologies, including AIX and IBMI, how to modernize the applications, how to adopt new technologies like Kubernetes, Red Hat technologies, and of course, our bigger activity is around Power AI, Watson machine learning in general. And in that context, we work closely with the IBM and H2O teams on particular use cases with customers and partners on H2O driverless AI. So this is the agenda. So first, a quick introduction of H2O driverless AI and why does it make sense, especially for AIX and or IBMI applications. Then I'm going to do a quick introduction of driverless AI, how it works, and maybe introduce some customer use cases and customer case examples. And then we will proceed with a live demonstration, how to build an enhanced and augmented CRM. In my case, it's going to be an IBMI application, a CRM application that I want to augment with scoring. And in my case, it's going to be a customer churn scoring pipeline. So this is what I'm going to do live. And then we'll maybe, finally, the session will end with a question and answer. But don't hesitate to ask if you have any questions while I'm speaking.
May I just remind people, sorry to interrupt Benoit, that if you do have questions, please add them to the chat window, any comments or suggestions as well into the chat window, and I'll keep an eye on it and interrupt Benoit as necessary. I have muted all lines, so please stay muted during this session. Thank you.
Thank you, Jyoti. So this is the global picture of what I'm going to introduce. So basically, so IBMI or AIX applications have the data. So it's really the new oil, and really the solution I'm going to introduce is really a way to take benefits and really use intensively the data you already have on such IBMI or AIX environments and create value for the business, for the line of business, and create some, for instance, predictive or scoring engine based on machine learning techniques. And how to do that, I'm going to introduce H2O driverless AI, which is an accelerated, so GPU accelerated and automatic machine learning solution that can help you build easily machine learning models from your Db2 or Oracle data that you already have on AIX and IBMI, integrate this with H2O driverless AI running on an AC922, which is our open power-based, power accelerated server. Integrate it, import the data, I would say, and create your models using all the features we have in H2O. Once the model trained and validated, export simply this predictive model to your favorite operating system, whether it be IBM AIX, or Linux. And the goal here, so it's really the bottom part, is to be able to really export the model, the predictive model that provides value to your application, deploy it on your IBM AIX, or Linux application locally. This is really a crucial, let's say, advantage. So why? Inference. Sorry, I should have mentioned it. Inference is about executing the model in production, integrated closely with your application. So why inferencing your machine learning models on IBM or AIX? Simply because it's so first, it's about maybe security or governance. We talked a lot about GDPR, all these kind of things. And yeah, I mean, it is a way to make sure that your predictive models are processed close to your IBM or AIX application, taking benefit of the power, reliability, availability, serviceability we have on the platform. And this is also one of the key drivers, I would say, is also to have the same SLA, I mean, service level agreement, that you already have on your business applications running on AIX and IBM, but bring this SLA to AI. And it's about executing the model with a low latency. So we are talking about high speed and potentially real-time inferencing from your application. That is to say, you want to score in real time some fraud or in my case, customer churn from your CRM. So it's about having, I mean, a low latency and minimal network delays between your application, existing application, and the model to infer. And last but not least, it's about combining AI and your application efficiently. That's it. I mean, you have everything in the same box. You have full control of it. It's not, I mean, invoking a model outside your Power AIX or IBM application server. Everything is running in the same box. So it's a way also to guarantee, let's say, a certain level of service and governance, etc. And it's really, I mean, this topic is really a topic of interest. When we talk to customers, we have many ongoing projects in our team. I mean, one of the top 3 challenges is first how to find enough data scientists in my organization. I want to build machine learning models needed by the line of business, but I don't have enough people to do that. The second driver is also the time, because building machine learning models can take weeks or months, and with this kind of solution we are proposing right now, it's, I mean, this can be reduced to days, for instance. So it's, I mean, time is also one of the key challenges. And the last one is trust. We talk about trusted AI. I will show you this driverless AI solution runs on your platform, and we have means to explain, interpret the decision made by the models, which is really key. Just, I mean, if we want to position this particular solution, so I'm going to focus on the right side today, but so on top of our AC922 and Power AI Watson Machine Learning Community Edition, we have 2 solutions. So Power AI Vision on the left side, which deals with pixels. So basically, each feature we're gonna process is a pixel. So it's basically for unstructured data, video, audio, It's about detection, inspection, use cases. On the right side, I'm going to focus on driverless AI. It's about transactional data. So basically, today we're going to focus on Db2 data that you already have on your IBM I system, or data coming from Oracle or Db2 on AIX. But basically, structured data, tabular data on the right side. It could be also time series, but of course it's related. We'll talk about sensors for IoT and all of these kind of use cases we have for structured data. So driverless AI also fits well with all these IoT use cases. And logs, as you see on the bottom right side, it's H2O driverless AI could also be used in any, let's say, cyber security use cases to detect any, let's say, strange events occurring on your IT. It could be also system logs to predict an outage. So it's about also predictive maintenance in general, IoT or IT logs. So all these kind of use cases dealing with structured data, tabular data. So how it works? Well, it's this is the high-level overview. On the left side, so first you have to ingest the data. So basically, you can connect driverless AI to any kind of data source, big data source, so HDFS for Hadoop, big data, etc. In my particular demonstration, I'm going to use, of course, an SQL connector, data connector, available out of the box with driverless AI. But it could have been other kinds of data sources like cloud object storage, BigQuery, etc. So all kinds of data sources you can connect to driverless AI. Then the second step is maybe to use driverless AI for automatic visualization. So it's really interesting to look at the data. So of course, maybe there is a data preparation phase in step one, but it's really useful to use this automatic visualization to maybe understand the data, see if there are some missing values. We'll talk about this in the demo. Detect outliers. So outliers basically are examples that you give to the model that whose, let's say, values are not in the expected range, I would say. So basically, this driverless AI solution helps you detect this kind of outliers that can bias your model at the end. So this is really crucial, and this automatic visualization can do the job for you. Well, could at least could maybe assist you in that step. And then the step 3 is about, it's really the core of the driverless AI solution. It's about automatic AutoML, automatic machine learning. So this is a fantastic. Driverless AI positioning is we provide you a data science in a box. So data scientists, as I said, it's a short supply, and with this kind of tool, you have all the automation you need to really quickly, fast provide predictive models really quickly with maximum automation. And when we say automation, it's about advanced feature engineering. We'll talk about this, which is really crucial to get, let's say, the precision that the business needs. It's also a toolbox with several algorithms, and this tool will automatically select the best, let's say, strategy based on the data, on your use case, and try several ones, iterate, and finally tune the model. At the end of this phase, of this phase 3, you are almost sure to have the best model and using the best technique. This phase is crucial and takes benefits of the power acceleration we have on the platform, because this training phase make an intensive use of the GPU acceleration. We are doing many matrices, multiplication when we train model. So we are using intensively the GPU acceleration we have on our AC922 with NVLink. And again, it's a good combination as we have many iterations needed for a training, and this using our technology can help you reduce this training phase from hours to minutes. So this is also one of the key, let's say, aspects of this solution, H2O Driverless AI integrated with our AC922 platform. And
Benoit,
yes.
sorry, there is a question regarding the data side. Can H2O connect to a time series database like InfluxDB?
That's a good question that I can. So there are many data connectors available. That's a good question. If InfluxDB or yeah, we have also other, let's say, time series database available. My answer would be yes, we can, but I can double check if you want, if there is an out-of-the-box data connector. But basically, driverless AI is I would say agnostic in terms of data, let's say, connectors. I mean, and so I would say yes, but I can double check. That's a good question.
Okay, thank you. I'll make a note of it.
Okay, thank you. The final step, which is really crucial, so training a model is okay, and as I said, one of the major, let's say, challenges is being able to put it in production. We have many R&D projects, machine learning projects, and the key challenge is to be able to export, I would say, the scoring, the models, and put them in production. And this is where driverless AI can help too. Basically, we are able, so first, interpretability, which is really key. We have, driverless AI can produce documentation out of the box, which could be really crucial for, I mean, auditing, etc. And interpretability is about compliance. We talk about GDPR, so the same. We have to be able maybe to explain why a particular model made such decision based on these inputs. So this tool generates what we call MLI, so machine learning interpretability, with various advanced techniques used by data scientists, grandmasters, I would say. But this tool automates all these steps and creates reports and explanations of the decisions that could be made by your models. That's really crucial, not having this black box effect. And in this particular step, the other let's say challenge is to be able to put it in production. So from driverless AI, we can generate a scoring pipeline. So it could be using the Java, Python, R technology and languages. And this is what I'm going to show you in the demo, how to export the model and run it directly on IBM I or AIX or any device. And it could be a mobile device. In our case, our point is about augmenting an existing application on IBM I or AIX with a close integration between the application and the scoring pipeline running on the same system for real-time prediction. So this is another view from data injection. So I would say the data preparation phase to the inference, step 4, use the model in production. Use cases, I won't spend too much time on that, but I'm going to just demonstrate in my demo the customer churn prediction in retail or any, I would say, industry. I would talk about collision fraud for, because I would talk about the PayPal use case. But as I said, it's a topic of interest on any industries. And we are working, for instance, in retail with customers, banking, fraud detection, KYC, know your customer, in IT and cybersecurity, predictive maintenance in general, in any industry, or we worked also with customers on supply chain optimization use case. So it's really rich. We have the data on IBM and AIX, and you just need additional tools to, let's say, provide this additional value, this predictive value functionalities, and driverless AI can help you do that. This is another example, so I wanted to highlight this particular customer case where driverless AI was used in that predictive. So it was basically the need was to detect buyer and seller collusion, so collusion fraud. And driverless AI, I mean, we reached matched the 10 years of expertise at the client side to detect this fraud. So it's also a way to automate and really accelerate, as I said, the model creation. And with this expert feature engineering, you can even reach what the customer could do manually, let's say in years, in several weeks with driverless AI. And this is the result. It's plus 6% in terms of accuracy, which you can imagine, I mean, means a huge reduction in loss. I mean, if you think about the very large number of transactions, PayPal, I mean, it's really huge, the gain, and the huge reduction in loss for this particular customer. And why the technology matters and the system matters, because GPU acceleration is key. If you want to reach this kind of accuracy and have a decent time to market, you have to try several techniques and work on your data, etc., and iterate. And at each iteration, you will make an intensive use of GPU acceleration. And it's concrete. We see that when we train a model, you can have real acceleration using GPUs, and you can have additional acceleration using GPUs on our Power platform. So this is what this slide is about, and this is really the customer testimony, which really, speaks by itself. This is demo time, so I don't know if you have any additional questions about the presentation.
There was one question that just popped up, Benoit. The question was PayPal using Power 9 technology?
This I'm not sure. I cannot say yes or no. Same. I keep this question for later, and we will talk about this. Yeah. But at the end of the presentation, I kept for you a few, let's say, recent references with driverless AI and the Power 9 technology, because we worked on these particular cases, or it was an official, let's say, reference we have. And so I shared with you a few pointers to this customer cases.
Okay, sounds good.
So the demo. I have many, let's say, other slides, but let's do a live demo, and then I will go back to the presentation to, let's say, conclude. So first of all, I'm going to introduce you my environment. So on one side, I've got my driverless AI. So let me log out. And this is running on my AC922. I've already bound a GPU to this particular instance. Behind the scenes, I won't spend too much time on infrastructure, but it's a container. So basically, driverless AI is really easy to install and maintain. It's based on Docker technology, running on our Red Hat on AC922, and so this is my particular driverless AI instance running on AC922. Right. The first things first is about data ingestion. So I have several ways to do that. So I'm going to use IBM I as an example, but keep in mind that it's really, of course, similar if you use a different data source like Oracle or Db2, Linux and X Windows, so particularly on AIX. So first, I've already pre-created a view with my CRM data. So in my case, I'm going to run a short SQL statement. So in my case, the library or the schema is Churn, and okay. So this is the data I want to use in my predictive model. So, and the goal is I've got my CRM running on my IBM application server, and the goal here is to provide a scoring for each of my customers in my CRM application. So basically based on dozens, so it's just a subset of the features, so the characteristics of each of my customers. But basically based on these characteristics, the features, I want to build a scoring model, a scoring pipeline, a new predictive model to help me score each of my customers. Is my customer happy or not? Will he leave or not? So it's the customer, I mean, a classic, I would say, customer churn scenario. But in that case, I'm going to use Driverless AI with the advanced AutoML features, with feature engineering. That's going to help me build a really precise and accurate model that I couldn't maybe reach if I have done it manually in very fast. And then once created and validated, export the model to my IBM partition. So if I go back, so maybe, yeah, I don't know if I have this. Okay, should have. Okay, so this is what I'm going to do. Sorry. Use this data from the data sources. Use Driverless AI to build the model and use it in production next to my IBM data and application for real-time scoring. So this is the data I have, and I've got I don't know, thousands and thousands of historical data on my IBM database. As I said, it's really the new oil, but how to provide value to the lines of business based on this historical data. So I pre-selected, so I'm prepared the data and pre-selected a few of the, some features for each customer. And at the end, I've already prepared this additional churn column, which is what we call the label. This is the column, so this is past historical data. So I know that this customer left, for instance. So I already prepared the data accordingly. And the goal is to use this prepared data in Driverless AI, create the model, and export it on IBM and use it with new data, of course. Okay? And at the end, the goal is to feed this additional column here. So this is the data I've already prepared. So we have many tools to prepare the data on AIX and IBM. We've got SQL, we've got many languages, Python, R, libraries like Pandas, like scikit-learn. So you can prepare the data, using SQL as I did, but you can also use, I also did it with scikit-learn on IBM. So I can prepare the data to feed my Driverless AI. Okay, so many open source technology coming with Yum and the open source communities on IBM and AIX. I have also a demo for that. Yeah. So once I'm happy with the data, I can export, simply export save results. So I can enable I can save as CSV file. Okay. Yeah, so I can use these save results, which should be activated. In my case, so I can extract it manually and import it in Driverless AI. Let's go back to Driverless AI now. I have my project, so I created a customer churn project. And what I'm going to do right now is import the data set the content of my DB2 I database, but it will be the same for any, let's say, Oracle or DB2 AIX database, and import it in Driverless AI. So in my case, I have many connectors. There are additional ones. I haven't configured all of them. And I configured a JDBC data connector. So let's use that one.
Sorry, Benoit, can we just clarify something before you move on? So the question is about the churn column. And the query is it used to highlight good trend and bad trend data? Is that what it's for? Or
so this is about providing to Driverless AI, I would say what we call a ground truth table. So this is the preparation phase that has to be done before, and this is about, I mean, we will do with Driverless AI, we will do supervised training. So we will provide to the model, at the training phase, the results, the past results. In my case, I want to create a binary classification, and I want to be able now to classify my new customers, my future customers, I would say, based on their characteristics. I want, once my model is trained, I want to be able to score and classify my new customers in the category yes or no. That's why I've already built this additional column, which is not in the original database. In my case, the CRM was, of course, it was a relational database where I had several tables, hundreds of tables. I created a view aggregating several columns that are useful to understand the phenomenon I observe. In my case, it's about providing information about each of my customers. And the last column is to answer your question, was created by me. And this is given the results, the past results. So this customer left. I know that this customer left based on these characteristics. So churn, yes. He left. And so based on historical data, I'm going to build this new column, which is really, what happened in the past.
So the results are already known for this set of data, which we are just using in order to train the model. Exactly. So that's the input, and then output will be, once we've trained the model, we'll end up with some scoring mechanism that will help with unknown data or new data.
Exactly, Jyoti. That's exactly what I wanted to say. So basically, this is my production data that never seen by the models, and I want to be able to score this new data in real time. Okay, so that's basically. So I pre-created this additional column. That's a good question. To be able to train my model based on past data, of course. And basically, the training is about iterating on this data and use several techniques and algorithms. And each algorithms and each iteration will try to guess this value. And based on the error, we will do like a feedback loop and adjust the algorithm parameters based on the error that we got on the previous iteration. And we will iterate hundreds of times. At the end, the model should be able to guess the good value for a new customer, I would say a new line, a new row, with a certain % of accuracy. But yeah, for preparing the data for the training phase, you have to, let's say, build this additional column. You have to do many other things. You have to maybe format. Usually, it's not a problem with database, because we have relational, I would say, constraints. We have constraints that let's say impose you some format, etc. But in many cases, you have maybe to work on the data itself, missing values, etc., or formatting the data. This is already done in my DB2 database. But the only thing I have to do now is I would say, based on what happened in the past with these customers, I populated this column that I will use for my training phase. And the goal at the end is to provide a new scoring pipeline used in production with new data.
Thank you.
You're welcome. So if I go back, let's create a new model. So in my case, I'm gonna connect using JDBC. So this is the IP address of my IBM I partition. This is the JT Open driver, JDBC driver that I've already pre-configured on Driverless AI. Okay. This is my user profile I'm going to use to connect the data. So again, I could have exported the data using ACS or any, let's say, DBA tool. In my case, I'm going to, let's say, stream and use a direct connection from Driverless AI to my IBM I database. So I don't duplicate the data, and I can, let's say, control where the data is and the duplication of the data. I mean, when you talk about GDPR or other regulations in place, it's really crucial to be able to know who has access to the data, etc. So in my case, I'm not gonna duplicate the data. I'm gonna use directly the data hosted on my IBM I or AIX partition. So this is my user profile. I have access to this particular view or data. This is my Churn, training, I would say. Let's name it data set I'm going to create. And I'm going to execute so I can, you know what? I'm lazy. So it's really simple. So this data has really been prepared, but I could have put maybe a more complex query in my case. So it's really a choice. And in my case, I'm gonna directly feed Driverless AI with data coming from my Db2 database. In my case, my CRM database. So it's performing a JDBC query, and it's gonna import thousands of data. In my case, I think it's not. There are something like 20, 21, 22 columns, features, and 7,000 columns, rows. So this is my newly created data set. And here is the first visualization. It's about, in my case, it's well balanced. I don't want to bias. I will introduce bias in my data. So this is also a way to have a quick view. Of course, I could have done it with SQL, but this is really, it gives you information about, as I said, outliers, so anomalies in the data, missing values. And in my case, I see that it's well balanced between male and female in my customer, let's say, database, which could, have an importance when I build a machine learning model. And this is okay. I have a really quick view. I can have the raw view of the data. So this is my data coming from my Db2 for I database, the one I show you in ACS. And then from that, I can visualize. Visualization ready. And I can have even more information. And this correlation graph, which can help you detect some correlations between features, columns. Of course, the AutoML, which will work on that and will maybe create additional columns, features in the feature engineering steps. But it will maybe also do some dimensional reduction and eliminate useless columns. Because I don't want my model to be created with I would say redundant columns. So if there are correlated columns, I want maybe to eliminate them. So it's also a way to see the correlation between some features, etc. So additional views, which could, really help a data scientist, I would say, a beginner, to have, a value-added, I would say, view of your data that you don't have it necessarily in DB2 out of the box with SQL, for instance. So if I go back to dataset, I can also split the dataset. So splitting is about, say, please use this out of these 7,000 rows. Please reserve me 200 for the validation of the testing phases at the end, and use only the 6,000 first rows for your training. Okay. So I can do that. I can say this one will be for training, but please, if I didn't do it previously in SQL in my on my database side, I can do it right now. So it's let's say train test, and I want to split it. I want to use 80%, for instance, or whatever, 80% of the row. Yeah. So for 80% for training, 20% for testing or validations. I can do that. And if I do save, it will automatically split the data and keep test data outside the training. And so I can use this additional data set for testing purposes. In my case, I'm going to use the auto split functionality. So remember, this is the one I imported from DB2 I can push the select button. I have several other functionalities. I won't have time to spend too much time on that. So basically, this will use so I can specify some particular validation and test datasets. So in my case, I could have put this test dataset in there. What I'm going to use is the auto split. So it's gonna split the original dataset in training, validation, and tests. And I don't want to hear about this split. But in the real situation, I would maybe do a manual, I would say, split of the data. The target column is really simple. It's the one I want to guess in production. This is the churn column. So in my case, it automatically detects that it's a classification problem compared to a regression, where I want to guess a scalar, an integer or float value, a numeric value. In my case, it's a classification, because in this column, in my database, remember, there is yes or no, 0, 1. So it's going to be a binary classification. And automatically, it will use different techniques to implement this binary classification, I would say. So for feature engineering and modeling, it's going to use LightGBM, XGBoost, etc. But I don't necessarily have to know about these techniques, which are the best of breed techniques that will be used by H2O Driverless AI. So I want to guess this new churn column and score my customer in real time. So this is the target or label column. And again, there is a live help required, so it explains what is what on the platform. What is also important is the settings. In my case, I'm going to let the default, but I can change plus, minus, accuracy, time, and interpretability, let's say cursor. And based on that, automatically, this will change the different strategies and recipes used by Driverless AI to build the model. Okay? I'm going to use the default one. And in my case, it detects 7,000 rows, examples of the phenomenon. So in my case, it's 7,000 customer information. Churn column, I want to guess. If there are some time columns, so in many use cases, you've got time series. So you can specify it and say this is the time column. You can detect it, but if you want to precise, and specifically set this column, you can do it. You can also fold, so it's a different way to, if you have several rows that are related, you can say this column is the key, let's say, between these rows, etc. So you can, out of the box, you can do many things depending on your use case. The metrics I'm going to use is AUC, which is the area on the curve. So it is the default scorer, but I could have chosen others. I like the default. This is basically what you want to give maybe to a data scientist, or if you participate to a data challenge, the matrix is really important. GPU enabled because it automatically detects that I have an NVIDIA V100 connected to this driverless AI instance. I'm going to use this acceleration for sure. And once I'm ready, okay, I have expert settings. If I want to eliminate recipes or, let's say, influence, I would say, the way driverless AI is going to create the model in general, I can do it. Okay, so many options available. Transformers, if I want to transform on the fly, etc. So many things. I put some links at the end if you want to know more about each of these functionalities. But I mean, keep it simple. I've selected the churn column. I want to guess in the future. I can launch the experiment, and automatically it's gonna create using recipes. It's gonna do some feature engineering. So feature engineering is in the middle. So it's create additional columns that are useful for. Let's say that data is slightly imbalanced. So yeah, one of the, I mean, some of the columns were imbalanced. We saw that in the visualization, not in the male-female column, but other columns were really unbalanced. So it can also, let's say, balance the data set accordingly. So yeah, features equals, remember, the features are characteristics of the phenomenon of the examples I want to, let's say, predict. So each of these columns is a feature in machine learning, a characteristic. If I go back, so it's getting started. So basically, it's going to use, so we can trace it. We have many views that are useful. You can let the training running. I mean, it's a batch. So you can, I mean, close the window, go back in 20 minutes, for instance. This is the settings I chose. This is a previous training, and I've got this result. I'm going to use it. For now, if I go back to the training I've just started, so it's going to take, in my case, by experience, something like 20 minutes for this particular example. It can take less, depending on the number of columns, features, and the number of rows. You have the real-time view. So for now, we haven't used the GPU yet, but it's going to be used intensively during the training phase. So this is where you will reduce the training phase, offloading most of the calculation, I would say, on GPUs. In my case, an AC922 V100 and NVLink. So it's running. I won't spend too much 30 minutes waiting for the. We will go back maybe to this screen. In the meantime, I've already prepared. So I think it's yesterday. I already trained model, and this is what you get at the end. Right, and this is the variable importance. So it added additional features, let's say columns, intermediary, I would say, features that was for, I mean, useful for predicting more accurately the results. But it's really, I mean, it could be an internal notion. You don't have to be aware of that. It took, I don't know, it was 20-25 minutes on that particular case with these settings. At the end, it used this XGBoost GBM, light GBM algorithms to build the model. I can interpret it, and interpreting is about being able to explain, I would say, to summarize. I mean, have a view of the, let's say, the features that have a real, let's say, interest and have the most, let's say, yeah, importance in general. So this is about. So in my case, for instance, the decision customer churn, yes or no, the contract column is the most important. And you see, and you have many, let's say, information about why did it make this decision, etc. I won't spend too much time on the MLI, but it's really it could be a webinar on its own. What is important at the end, if I come back to the experiment, is I want now to, I'm happy with this result. If you have a look to the metric, I have the 0.84% of accuracy, which is okay with my business. The life of business is happy with that. I can now detect the customer churn with this, let's say, accuracy. Let's put it in production. So I can download predictions. I can score on another data set, for instance, in real time. I will do that on IBM directly, but I also provide an additional data set to test the model from the GUI itself. What I'm going to do right now is download the module scoring pipeline, which is one of the, in my case, I'm going to use the Java version, but I could have used the Python 3.6, or R. All of them are running on AIX and IBM. They are all available. In my case, I'm going to push the download scoring pipeline, and in my case, it's going to download the module.zip. It's lightweight, right? It's really light. And I'm going to import it in my IBM partition. So for this purpose, I'm going to... This is my IBM partition. So I train the model. I have 0.85 accuracy. I validated with the lines of business, and now I'm gonna deploy it. So this is my IBM 7.3. It's not a fake. So I'm running 7.3. Okay. So basically I'm okay. I already. So the scoring.zip already FTP the scoring.zip on my IBM IFS. So, but it's really the same on the AIX, right? Just FTP, SCP, whatever, the scoring pipeline. And it's really, I mean, a few megabytes, really. And once inflated, it generates this folder. What's in this, so I'm gonna, module pipeline, ls, and this contains a README, an H2O jar file that is used, necessary to run the Java scoring pipeline. Example, which is a subset of my test data set, which was not used, examples that were not used in the training phase, of course. And this is basically what I need. I need a Java JVM. In my case, 64-bit JVM, but it's it's the JV1 I don't know license product installed on my IBM partition, but same JVM, the J9. Well, let's have a look to the examples I have. Quick things. And additional, let's say, it's CSV file with all the columns I need, except the churn column, right? Because this I don't have. This is the future values. This is my production data, extracted from Db2, for instance. So I'm going to use it and say, please run example dot. Okay. And this is going to invoke and score each of my new customers on my IBM. Okay, and for each of my, each line, I'm going to score. In my case, for instance, the first customer I provided in input has been classified in churn no, and this is, at 79%, let's say, confidence. Okay, so this is a binary classifier, and this one is classified in no, but it could have been, yes. So depending on the data I provided, based on the data in my CRM, my customers are now scored in real time. So as you can see, it's really, it's really fast, milliseconds. Okay, this is a key, let's say, feature of driverless AI. this module scoring pipeline. And if I go back to my application here, this is the initial situation, and now I want to provide more value to my to the business, simply adding more, scoring here. So I'm going to push this scoring button, and it's going to do exactly the same, but except that this is a web application running on my existing Power environment, and I'm scoring in real time. Okay, and this is the additional value. So in my case, it's a batch online, I would say, but it could have been real time each time or let's say scheduled a task. And this is additional information. In my case, maybe I'm going to address these particular customers differently because they have been classified in the Churn yes column, and it's with this particular confidence. So I'm going to sort the customers based on this scoring, for instance. And behind the scenes, by the way, I used open source technologies. I don't know if you can see that. I'm a Node-RED fan. So Node-RED is running on Node.js on IBM I or AIX. We're using here, of course, we are on Db2, we are on IBM I. So in real time, we are, let's say, querying in the CRM, production CRM database, then invoking in real time the scoring pipeline, as I did manually in my shell. This time it's done automatically, and feed my CRM with the scoring data. And so I'm enriching the data, and I display it in a view, which is exactly the one I've just. So this is my view, and I can score in real time. And each time I score, it's behind the scenes, even if you, it's running a JVM. So there are different ways to integrate. So it could have been an integration with ILE, COBOL, RPG application with this scoring pipeline. In my case, it's a Node.js application, but it's really an example. So I really love this prototyping stuff with Driverless AI and Node-RED. And it took a few hours to do that. It's really simple with Db2 for I. And yeah, so this was the goal. This is what I used. Okay, I detailed it in the presentation, and at the end, I augment the data and run the scoring pipeline, the AI model, on the fly, locally, close to the application and data. And of course, at the end, I have to once in a while, of course, monitor and test from the Driverless AI GUI, for instance, the model, and validate it because sometimes the phenomenon I observe can change. And I have to make sure that this model is still accurate. So yeah, and then I have to maybe ingest new data coming from the production and iterate and update the existing models and export them as I would say a microservice on my AIX and IBM I, and invoke this scoring for my existing ILE, Java, PHP application. So this is really a loop where I have make sure that the model is still accurate, right? So, and I provided a link to the demo with a video and presentation. You will have the presentation. I also detail all the steps for those who couldn't attend. I have maybe the final. I prefer that. So yeah, it's about being able to prototype. So I love Node-RED for that. I've been working on Db2 for I. I created this node to prototype with customers, and we are using it with some of the customers here. So it could be used in any, let's say, use cases. And I talked about IoT use cases with Driverless AI. So you can do IoT, of course, with Node-RED and ingest, this data and feed your scoring pipeline with just this kind of flow. In my case, it was the CRM integration, but it could have been, a different use case, of course. And everything is running on either IBM I or AIX. These technologies are available on the platform. So this is really we take benefits of this driverless AI technology on the training phase and the inference phase. Just to finish, and maybe a question and answer. I put you a few links. So this is a solution brief, vision. We talked about there was a question about references on Power, etc. We have some references. So a direct link to this. If you want to know more about driverless AI in general, there is tutorials available online. There is an H2O Driverless AI and AC922 bundle, just for you to be aware of that. Of course, we can help. I introduced myself at the beginning because I wanted to make sure, for you to know that who is speaking. But yeah, we can help. So don't hesitate. In Europe, we have a center of competency. We can host, any environment for your particular proof of concept testing environment. For tabular, I would say structured data with driverless AI or vision with Power AI and vision, for instance. Of course, there is a CSSC worldwide, so you have also to take benefits of the center. So a direct link if you want to know more. And of course, I wanted to I think it's attending. So I would. So Louis is responsible for the offering. So he helped me build this presentation, and we work together on this particular demonstration. Is responsible for the offering on everything related to accelerating machine learning, including H2O on AC922 and Power. Link to the demo portal, and if you want to know more, our other presentations and etc. So yeah, you can get started quickly with a trial version of the driverless AI. And if you want to go further, you can contact us, and we can put in place a POC environment for a particular use case and customer. That's what we do with users, so common user groups, with particular customers, with business partners interested. So don't hesitate to contact us. So thank you very much. I think I have so many questions in the well. I didn't see direct questions, but JOT, maybe there are several questions.
Yes. Thank you, Benoit. I think most of them have been answered. There's one additional one at the end, which somebody's asking: Does Windows OS also execute the scoring pipeline?
The answer is yes. Yeah. It's portable. So my point was to illustrate a close integration between an application and the Power application and the scoring pipeline. But if the answer is, can I run the scoring pipeline for inference on my Windows? The answer is yes, because it's based on Python and Java. If the question is, can I run driverless AI? The answer is no. Driverless AI can be run on Linux and will automatically use GPUs when available on the system. So training, it's Linux, in our case AC922 with at least 2 GPUs to 6. And for the inference, you can, this technology can be really spread across different types of device. Depending on the use case, it could run on a mobile device if Java or Python is supported. So it's really it has to be studied, but yeah, basically it's portable. Mm-hmm.
Great, thank you, Benoit. So whilst people are thinking of other questions, I just thought I would say thanks for taking us through this today. And in my opinion, this is my summary, and you can correct me when I've gone wrong, but you've taken us through kind of the data ingestion point. So you may have data that is on your IBM I or AIX partition at the moment, using whatever database you've got. So Db2 or Oracle, depending on which platform you're running on. You've got your data there already. You're ingesting that, and rather than manually trying to gain insights from it, the one way that you could do this is to take that data and pull it into something like Driverless AI, which happens to be running on the Power AC922 in this demo, which has got GPUs. And the reason you might want to do that, you're not porting the data, we're actually getting it via JDBC directly from the database. And the reason we might want to do this is to get more accurate and faster results and insights from this data, where you may not have data scientists working on this solution, but you do have the ability to use Driverless AI with all its expertise built into the product. And then from there, you took us through to training of the data. So we fed it data that we already knew whether a customer had churned or not. We fed it that data to train it, create a model, and then we ported that model as a Java, I forget the name, but mojo.zip is what you
the
had.
scoring pipeline,
The scoring pipeline, that's it. And that can be ported to, in our case, it was back onto the IBM I, but it could be to a different platform, could be integrated into all sorts of different applications to be used to get an idea of, for new data, whether a customer is going to churn or not.
Exactly. And in my case, it was a customer churn scoring, but we have many other ongoing projects in supply chain optimizations, on fraud detection, basically. So many use cases based on the existing data we have on the platform, IBM I, AIX, which is really key. Exactly. Many use cases, and the goal at the end is to really deploy this scoring pipeline, this real-time, high-speed scoring pipeline in your applications.
Cool. Thank you so much. I don't see any other questions in the chat window. So I will take a copy of the questions that we still need to look into, and we'll make sure that we get back to the people who ask those questions, or maybe put something in the where I'm going to post the replay information. We can add a couple of lines with the answers. Do you have anything else you wanted to add, Benoit?
No, thank you very much for inviting me. I was very happy to present and introduce this demonstration. And yeah, if you have any questions, additional questions, don't hesitate to contact me on any, let's say, open source on IBM I, but also AI integration with, Driverless AI, etc. And yeah, don't hesitate to contact me. And thank you again for inviting me, and thank you for attending this webinar. Thank you.
Well, thank you very much, Benoit, for delivering the session. It was very, very useful, and maybe in the future we can have you come back and do another topic or a related topic. I just wanted to also say thanks to everyone for participating and tell you a little bit about what's coming up next. So on 6th of November, at 10 o'clock UK time, and I will post details later so you can look at your local timeline as well. We have David Spurway and Turgut Ken, who are going to be talking about Power Enterprise Pools. So Treasure Hunting with Power Enterprise Pools is the title, and I will send, with the replay that I send later on today, I will also send information about the upcoming sessions. So if you are not on the subscribers list, just send me an email. I'll post my email into the chat window in a moment, and I hope that you can join us during that session. There is also, just wanted to highlight, there's an AIX community survey going on at the moment, and I'll post a link to the survey into the chat window as well. If you have a chance, please do take part in that survey. It helps IBM focus on what to bring to clients in the future. So it's always a good thing to take part and have your say. Okay, I think that's it from me. So I'm going to stop the recording and then we'll continue. So Benoit, if you could stop sharing your screen.
Yep, sure.